We shall continue our lecture from where we stopped from our first class last week lah, which is to generate the AC and DC voltage. Okay, so we stop at the probe connecting between function generator and oscilloscope. So the BNC plug lah. Alright. Now we will go into our alternating current, our AC, and look more deeply into their characteristics lah of alternating current. So the first one that we are going to go through today is the sine waves, AC. All right. So if we have a sine wave, then we have to make sure that we know how to read the signal in the waveform, in the sine waveform. Okay. So from this graph we have here, all right. If you look at this graph, it is a one full cycle of a sine waves, which are shown in red colored lines. So itu kita punya waveform. And then, and then from this waveform, basically we can obtain our values of voltages, VRMS, V average, V peak to peak, as well as for um, our time and frequency lah. Alright. So if you look into this diagram, I have shown here that the V peak lines, which is situated here. So this is where the value of your highest value of your voltage from your waveform. So that will be the highest value for positive value. And then you have another one which is down here, which will be the highest value of the negative voltage value for this sine wave. Okay, so that is this at this point it is known as the V peak. Okay, value voltage tertinggi lah. And then for V peak to peak, we have to make sure that we obtain the value from the positive peak until negative peak. So it will be from the positive V peak plus with negative V peak. All right. So when you are calculating the value of your V peak to peak, you just ignore the negative value of the negative V peak lah. So you just add V peak for the positive and the negative part without the negative of the V peak, then you will get the V peak to peak. So let's say the V peak is 10 volt. So your V peak to peak will be 10 add up with another 10 from the negative part. So you'll get 20 volt. Alright. So that is V peak to peak. And then we have our V average. So V average is basically you divide your V peak into 2. Okay, the average value of your V peak. So for 10 voltage of V peak, the average is 5 volt lah. And then we have our VRMS. So VRMS, the equation for VRMS is this one, 1 over square root of 2 times with V peak. So let's say your V peak just now is 10 volt, so your VRMS will be 7.07 volt, because 1 over square root of 2 is 0.707. So you times with 10, the value will be 7.07 volt. Alright, so that is the value for VRMS lah. So there are four different values that you can obtain: V peak, V peak to peak, V average, and VRMS. Okay, so we look in terms of the example here. Alright, so from this diagram we can see that the value of the V peak is 10 volt. Okay, so obviously when the peak voltage is 10 volt, the peak to peak voltage will be 10 10 add up with 10, another 10. So the V peak to peak is 20 volt. All right, for the period, okay, when you are obtaining the value of the period, make sure you obtain the value after the waveform has complete one full cycle. So when does the wave complete one full cycle? if you start here from 0, it will end when it reach 50. Okay, so one half cycle on top on the positive part, another half cycle on the negative part. Okay, so if you move the positive part on top of this negative part, the value will the waveform will becomes one full cycle. So then you will obtain one full cycle for your waveform. So that is when your period values will be obtained. So from here, if you start your counting from 0, so one full cycle will be at 50. If you start from 25, then it will stop at 75. But basically it is 50 lah, 50 millisecond, because time, the unit is millisecond. So for one full cycle, the period is 50 millisecond, which is equivalent to 0.05 second. Okay, you move the point by converting the millis. Thus, you can calculate the value of the frequency of your sine wave, of your waveform, if you have your time. So now you know that the time is 0.05 second. So frequency, the equation is always F, which is equivalent to 1 over T, where your T is your period just now. So 1 over 0.05, which is equivalent to 20 Hertz. So it means that for this waveform, the frequency is 20 Hertz with the peak voltage of 10 volt and the peak-to-peak voltage is 20 volt. Okay, how about VRMS? Any idea? Who has any idea what is the value of VRMS here? Guys?
Yes, sir.
Ada siapa-siapa tahu tak value VRMS berapa? For this waveform, for this sine wave. Okay, so basically you just use this equation lah. VRMS is equivalent to 1 over square root 2 times with V peak. So 1 over square root 2 is 0.707. You multiply it with V peak. So 0.707 times 10. So the VRMS is 7.07 volt lah. Okay, so basically there are equations for this, for analyzing your waveform. It's just that they are using only simple equation lah. Kalau you tengok pun equation dia pendek-pendek je. Alright. Okay, another example here. So the period is for one full cycle. If it starts from 0, it will stop at 24. If you start from 12, it will stop at 36 and so on. So the period is 24, unit is microsecond, 24 microsecond. Thus the frequency is equivalent to 1 over time, which is 1 over 24 microsecond, which is equivalent to 41.7 kilohertz. So that is your frequency for this waveform. So the peak voltage is 5 volt, and then the negative voltage is also negative 5, is 5 volt as well. So the V peak to peak is from 5 until negative 5, which is 10 volt lah. Okay, the same way how you calculate for this one just now. They are the same. And then for the VRMS, so 0.707, which is 1 over square root 2 times with 5. So you will get somewhere around 3.6 volt lah. So that is your VRMS. Around that volt lah, 3.5 something. Okay. Alright, that is for sine wave. For square waves, so how do you read the signal? V peak is equivalent to V, which is the same way how you calculate, how you analyze from the sine waves just now. From the zero value of your voltage until the straight line. Okay, the line yang berdatar ni lah. Okay, the vertical line ni. Alright. And then from 0 until this line here, that will be your V peak to peak. V peak. And then if you add up with the negative part, which is this one here, you will get the V peak to peak. Alright. But for this waveform, the V average is equivalent to V peak. So there is no equation for V average. So you just obtain the value of your V peak, then that is also the value of your V average. Okay, that is also for VRMS. For square waveforms, the VRMS is also equivalent to V peak. So you don't have to use this equation for sine waves here. Okay, so they are different in terms of their values because which is caused by the structure of the waveform itself lah. Okay, because for square waves, basically the values of the peak is constant. Means that kalau value dia 10, dia akan 10 sepanjang masa. But for sine wave, it will increase and decrease depends on dia punya time lah. So from here it will become 0. Somewhere here 4, 5, 6, 7 up until 10, then back to 0. So dia punya value of VRMS dengan V average dia lain dia punya calculation. But for square waveforms, they are straightforward because they are straight lines, so the value will be the same lah. Triangle waves. So how to read the signal in triangle waveform? So for V peak, you are still using the same way of for all the waveforms calculation, how to obtain them from 0 up until the most tip of your waveform, paling tinggi sekali berapa. So that is your V peak. For V peak to peak, you just add up the positive and the negative part, you will get the V peak to peak value. For VRMS, it is 1 over square root 3, not 1 over square root 2. Okay, for sine waves just now, it is 1 over square root 3. And then multiply it with your V peak. But for V average of triangular waves, it is equivalent to 1 over 2 of the V peak, half of V peak. Then you will obtain your V average. Okay, so different type of waveform requires different types of calculation in terms of obtaining their V peak, their V peak to peak, their VRMS and their V average lah. But in terms of what we call it, in terms of frequency, time, and the period, it is still the same. Okay, just make sure that when you are calculating the waveforms period, make sure they are calculated from the starting point up until their full cycle lah. So from 0 up until 360 degrees. Okay, the easiest way for you to determine that you are measuring them correctly, just make sure that you are able to design a full cycle if you combine the positive part with the negative part. Okay, you ubah segitiga atas ni pergi ke segitiga atas segitiga bawah ni, you will get one full cycle. So it means that is your time period that you should calculate. All right, example here, V peak for this waveform. Okay, so the V peak, if you look at this, the time per division. So this is what you obtain normally in your oscilloscope, on your oscilloscope. So for this axis here, the value is 2 volt per division. So it means that from this line to this line is equivalent to 2 volts. Okay, but for your time axis, CX ni, it is equivalent to 50 microsecond for time per division. So means that from this line to this line, it is equivalent to 50 microsecond. So this is your waveform. Okay, if you look at it, it is only available on the positive side of this display, dekat bahagian positif sahaja. So how do we obtain the value of the V peak? From this line of 0 for the voltage here until the maximum value of this waveform. So let's say we are assuming starting from 0 up until this point here, it is 1, 2, 3. Okay, so 3 division. And then we have already known each of this division is equivalent to 2 volts. So it means that from this point up until the V peak, it is equivalent to 3 division times with 2 volts. So that is why you obtain the V peak is equivalent to 6 volt. Alright. And then the V peak to peak. Okay. I've obtained the value here as 6 volt. The reason why the V peak to peak is not add up like this, like the previous example, is because if you look at this waveform as well, it is only available on the positive side sahaja. So it means that the peak to peak is just from the most zero value of the voltage until the peak values. Unless if you have the waveform comes from the positive side and then goes to the negative side, then the V peak to peak dia akan jadi double the value lah. If not, if it is like this, then the value of the V peak to peak is still equivalent to the V peak lah. Okay, so VRMS is 0.707 multiplied with V peak, which is 4.242 volts. V average is equivalent to 2 over pi multiplied with V peak, which is equivalent to 3.819. Okay, just use the equation yang saya letak dekat sini tadi. Okay, semua ada equation dia dekat situ. Time, okay, this is a bit catchy lah because we have to look at it properly. Okay, let's say I'm starting from this point lah because I think it is easier because it is starting from exactly this line here. So if I want to get one full cycle, I have to make sure that I calculate them from here up until here and then another one which is here. So that is what I have to do. Okay, means that if I move this, let's say I move this, the first one to this side and then I mirror it and then it will become one full cycle. So your one full cycle for this waveform is from this point and then up until this point here. Alright, so you have to calculate how many divisions are there. So from here until here it is 1, up until here it is 2, and then up until here I am assuming it is as 3 lah. 3 division for one full cycle. Okay, from here 1, 2, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. So 5, you know, senggat tu ada 5 senggat 3 kali. So means that 3 division lah because one division you have 1, 2, 3, 4, 5. Ada 5 part, 5 senggat. Alright. So you have 3 division and you have to multiply with the scale which is 50 microsecond. So you will get 150 microsecond. So that is the period for this waveform. Frequency 1 over your time, which is 1 over 150 micro. So it is equivalent to 6.67 kilohertz. So that is how you obtain your values. Okay. Alright, another example here, V peak to peak. If you look at this part here, so we start from here, 1, 2, 3, 3.2, 3.4, 3.6, 3.8. Okay, so 3.8 division from the negative peak up until the most positive peak. Okay, so 3.8 multiply with the value of each division, where from channel 1 the value is 5 volt. So for one division here is equivalent to 5 volts. So the V peak to peak is equivalent to 3.8 times 5 volt, which is 19 volt. Okay. And then only I can obtain the V peak, which is 9.5. So how do I obtain 9.5? I divide 19 with 2. So I will obtain 9.5 volt for V peak. Okay, now it is just that why does this waveform calculated from the V peak to peak, then only V peak, whereas just now we calculate the V peak first, then we calculate the V peak to peak. Okay, the reason why, because if you look at this waveform here, it is not symmetrical in terms of positive and negative value. Okay, let's say if you are taking from this vertical line here, for the negative part, it is taking 2 complete division. Alright, but for the positive part, it is not taking 2 complete division. It stops somewhere 0.2 from the second division. So we can't exactly calculate from here to here as the V peak, and then from here to here from the negative V peak, because the value will be different. So that is why I move the waveform up until the most zero. I assume that this line is 0, so that I calculate the division up from the negative until the positive peak. Okay, how many division, and then I will multiply it with the scale 5 volt. So that is how I obtain 19 volt. Okay, dia terbalik. Example 1 dengan example 2 dapat V peak dahulu ataupun dapat V peak to peak dahulu. Okay, the reason why saya cakap tadi, sebab daripada kosong ke positif tak sama dengan kosong ke negatif. So kita calculate dulu V peak to peak, and then we divide them into 2, we will get our V peak lah. VRMS, so 0.707. Macam mana dapat 0.707? It is equivalent to 1 over square root 2. Multiply with 9.5, the value is 6.7 volt. V average 2 over pi multiply with V peak, which is 6.0471. Time, okay, so this is also a bit catchy. You have to make sure that you are obtaining the correct values. Okay, so for this part, I would like to use this point here as my starting point. So for one full cycle, it should be starting from here, and then it will go through the negative part up until positive part, and then it will stop somewhere here. So this point up until here, that is their one full cycle. Okay, their 360 cycle. So if you calculate from here until here, it is 1 division, 2 division, 3 division, and then somewhere here around the third notch. Okay, senggat yang ketiga. So sebelum tu 5. So 1, 2, 3.5. So time is equivalent to division dia 3.5, 3.5. Multiply with the scale. So the time scale is 250 microsecond. So you will get 875 microsecond. So that is your period, your time. Then of course you can calculate your frequency 1 over time. You will get 1.14 kilohertz. Alright, so they are very straightforward. You just obtain the values, multiply with the division values, and then you will get your answer lah. Very straightforward sebenarnya. Okay, it is just that when you are getting the reading, make sure you look at the division properly lah. Your starting point up until your end point. Okay, from your starting point here until your one full cycle point dekat mana. Just make sure that you are reading them correctly. Alright, that is what you can obtain normally on the oscilloscope. Okay, so this is an example how you will get on your oscilloscope. Macam ni lah. You takkan dapat macam ni. Ini lukis sendiri, cantik. Okay, you boleh letak dia dekat mana. You can put it whatever you like, the waveform, so that it is easier for you to calculate. But this is the normal waveform that you can obtain from the oscilloscope. Okay, now we go into the analog and digital trainer. Okay, so this trainer, we have them in our labs. Okay, I don't know if you have used them before from your previous subject, but you will not be using them this semester lah, obviously, because you will not be constructing your circuit in the labs. Alright, so basically this analog and digital trainer, we have them in our lab. All of our electrical and electronic labs, we have them for designing and analyzing our circuit and everything lah. Okay, so part of them, we have the on the main switch on here, which is available here. Okay, all this part, they are separated in terms of this way lah. Okay, so kita pecahkan dari sini, kita turun ke bawah, and then here, and then so on lah sampai atas. Power supply, okay, we want to generate our supply up until 15 or negative 15 volt, okay, which is available here. Alright, and then we have our potentiometer. What is potentiometer? Adjustable resistor. Resistor boleh ubah. Okay, VR1 up until 1K, VR2 up until 100K ohm. And then down here we have our function gen. Okay, to generate frequency variable, amplitude, frequency, waveform selector. If you want to select types of waveform, sine wave, square waveform, triangular waveform. And then we have our output and our ground point. We can connect them here, or you have TTL mode for your ICs. Okay. Frequency range. What is your frequency that you want to use? Your amplitude. What is the amplitude of your waveform? You can use them here. Alright. And then you have switches as an input signal or supply. So here you have switches, toggle switch, 0101. Up here you have LEDs. You can use them as your output, or you can use them as your input as well, indicating that if you are switching this switch on, then it will turn on. Okay, so that you know which switch are on at that particular time lah. LED as an output signal indicator, which is up here. Okay, normally we use this for electrical electronic basic circuit, as well as you can use up until counter circuit. Okay, you can use them. And then you have the 7-segment display here, output display to display number 0 up until 9. Okay, adapter both for banana socket and BNC jack point. Okay, you can connect the banana, which is the red one. The silver one is the BNC. Okay, the same one that you used for your oscilloscope and your function generator before. Okay, boleh connectkan ke sini. Okay, this is analog trainer. So they are equipped with pulse switches, which is where is it? Dekat sini. Okay, dekat this 2 point here. This is the pulse switches. Okay, so 2 set of output display, inverse A, inverse B, B, which is also available in this trainer here, which is here. Okay, for this one, it is situated here. For the blue one, it is situated down here. So what is the function of these switches, pulse switches? If you want to create a circuit which requires pulses. Okay, pulses. What is pulses? For example, if you are designing a counter circuit. So a counter circuit ni dia memerlukan pulse for it to calculate. So means that you can push them once, means that you are giving the circuit a pulse. And then you push the second one, second time, second pulse will be applied to your circuit and so on lah. So dia makin lama makin tambah. So it is up to you lah. Alright, so pulse circuit is very important in terms if you are later on lah, bila you dah masuk subject digital electronics, FPGAs and everything, you will be using this button later on lah for designing the what we call it, the counter circuit. Alright. Construction on the breadboard. So basically, if you look at this here, this trainer here, this white thing in the middle of this trainer is known as the breadboard. Okay, but normally bila you pakai dekat lab, dia tak ada lah benda ni. Technician dah remove. You have to use your own breadboard lah basically. Okay, so dekat sini kita tengok lah pasal breadboard. Construction on the breadboard, which is used to make up temporary circuits for testing or to try out an idea. Okay, so breadboard is just for testing. Okay, you want to do simple simulations. Okay, but it is not suitable in terms if you are designing a project or anything. You nak try dulu, test your circuit, you can use them lah. Okay, so for this breadboard, no soldering is required. So therefore, it makes the process of experimenting and designing circuit much more easier. Parts will not be damaged, so they will be available to reuse afterward. Okay, so the figure shows a circuit constructed on a breadboard. So this is how an example of a design circuit on a breadboard. Okay, so you have your components: LED, resistors, capacitor, IC, semua ada dekat dalam ni. And the yellow, red and black things are called jumper. Jumper ni wire lah, wire jumper. We use them for connections. Kita nak buat connections between the components. The connectivity. So this is an example of a breadboard that you should have basically as an electrical electronic engineer students. Okay. So this breadboard normally costs around 4 or 5 ringgit lah, if I'm not mistaken, around that price lah. So it is basically quite small. You can place about 4 to 5 ICs only, and then kalau banyak lagi components means that you require more than one breadboard lah. Okay, so this is the connectivity. Okay, you have here these 2 lines of vertical and then 2 lines of vertical here as well, which is these two, and it is not shown on my screen here because okay. These 2 lines representing the 2 lines on top here. These 2 lines here representing these 2 vertical lines on this bottom part. And then these horizontal lines, which is 5 for each of the lines. 5 on the top side and 5 on the bottom side, which is these 2. Alright. So the connectivity, they are different from the top and the bottom 2. Because the bottom 2, the connection is in vertical, melintang macam ni. Okay, untuk yang 2 tengah ni, 10 lubang ni adalah secara horizontal, menegak. Okay, so dia berbeza lah in terms of connection. So make sure you know dia punya connectivity, how they are connected together between each of these slots here. If you connect them salah, then you will not get the output lah. Okay. So this breadboard have many tiny sockets, which is called holes, arranged on a 0.1 inch grid. So that is the size, sangat kecil. So the lid of most component can be pushed straight in the hole. So example here for this LED, dia punya lid, dia punya kaki ni, you boleh terus tolak ke dalam tu, pin dia akan grip. Masuk dekat dalam, pin tu akan grip supaya dia tak bergerak. ICs are placed across the central gap with their notch or dot to the left. So this is ICs, the black thing here. Alright. So you have here example, a connection of a resistor. Okay, you can place wherever you want lah, as long as they are connected regard to this connectivity. Okay, salah letak, salah nilai output. But for IC, normally kita akan placekan dia in between of these 5, in the middle. So means that somewhere on this part here lah. So 1 rows of pin on top and then another rows of pin on the bottom part here. And then make sure the notch of the ICs are placed to the left. So notch ni yang putih ni, dia ada lekuk ataupun you have this bubble on top of here. Okay, the reason why, this is how you know which pins representing the number of each of the pins available in the ICs. Okay, so if you place it like this, pins yang bawah ni akan jadi 1. First pin, second pin, third pin, fourth pins, up until 8 pins lah. Depends on the number of pins yang available lah. Ada yang sampai 16 pin, ada yang ada 14 pin. Different ICs have different number of pins. Okay, so always practice that when you place your IC, your notch should be to the left. So it is easier for you to identify which pins are number 1, which pins are for VCC, which pins are used for ground and etc. lah. Okay. For continuity test of your breadboard, to check either your breadboard connectivity is still working. Maksudnya tak rosak, okay, tak putus connection dia. So it is the art of checking if there is an electrical connection between 2 points. So we have to use the multimeter to check the connection on your breadboard. Okay. Example here, if you place 1 point here and another point on this 1, 2, 3, the fourth row, okay, you will get a value of on your multimeter. Means that there are continuity, means that there are connections, which comes from the black probe going to the this point and then transfer to the red probe back into the multimeter. So you will have readings here. Okay, and then if you put it in series like this, and then your value will become 0, means that there is no continuity. Okay, the reason why, because between this point and this point, they are not connected together. Okay, just compared to this breadboard connectivity diagram here. If you place it here and here, then there will be connectivity. But if you place it somewhere here to this point here, there will be no connectivity. Okay, so the values will become 0. Measuring techniques here, okay, we have an example of a circuit of a 9 volt. For example, this is our battery with a resistor 1 of 10K and resistor 2 of 5K. So you place them like this for R1 from this point up until this point, and then R2 at the same column, another row, connect one pin of this R2 and then another pin which is here. Okay, so the positive pin of the resistors will go to the 9 volt. So you jump a cable to this line, and this whole line will be connected to your 9 volt terminal. And then another one which is from this R2, the last pin of R2 will be connected to this line here, this row, which will be connected to the negative terminal of your voltage of your battery. So positive battery, negative battery. So the connection will be from the battery goes to this part here, this line, and then will be transferred into this row, and then it will go through the R1 before it is transferred to R2, and then from R2 will be transferred into the negative voltage, negative terminal voltage. Okay. Output measuring technique, output from function generator. Okay, function generator, this one and this one is exactly the same as terminal positive and terminal negative lah, but it is using function generator, because just now we are using batteries, now we are using function generator. Same connection, going to same pins, same jumper and input and output of the generator. How do you obtain the waveform of R2? So you have to make sure the red probe of your oscilloscope is connected to this point here, where it is connected to the output of R1 and input of R2, which is this point here lah. And then another probe, the black probe of the oscilloscope will go connected to the output of R2, which is here. Okay, so you measure this, you will obtain the output waveform of R2 from this circuit, from displayed on your oscilloscope. Okay. Troubleshooting technique. Rules to construct circuit. Always keep your work neat. Okay, of course, this is very important. Neat work, neat construction will help you in analyzing any errors of your circuit. Okay, kalau you susun semua terlampau rapat and everything, sangat susah you nak detect kalau ada salah. Keep your component leads short. Okay, so you dah cucuk dia macam ni, make sure jangan terjuntai panjang-panjang. Okay, just keep them short to make sure that it is neat. And then kalau dia panjang terjuntai, then it is easier for you to touch them. Senang terjatuh, tersenggol ke apa, so dia senang nak patah atau tercabut lah. Use different colors of jumpers for different kind of function. Okay, macam ni lah. Okay, black is for ground, red is for the one connected to the positive voltage. Okay, yang yellow ni untuk interconnections. Macam tu lah lebih kurang. Avoid both overcrowding and excessive spacing. Okay, jangan terlampau overcrowd, jangan terlampau besar lah. Okay, just sedang-sedang sahajalah. Never force components into the breadboard socket contacts. So jangan, if you try to place a pin of your resistor into the socket but it couldn't go through the slot, never force them. Just do it gently lah, masukkan dia. Kalau tak boleh, use another slot. Okay. Never bend a component lead at the body of the component. So ini nanti kita akan tengok next slide. Means that I'll show you an example. For example, okay, this resistor lah. When you bend them, make sure you take distance from the body until the bend part lah, tempat yang you nak bengkokkan tu. Not exactly at the body of the resistor. Okay, dia akan senang patah. Leave at least a quarter of lead length available to plug into the breadboard socket itself. Okay, so that is for chapter 2. Kita tengok sikit lah, sini ada example yang which is will show you about the bending techniques lah. So still electronic circuit development, which is also related to chapter 2. So the objective is for you to know how to plan the component layout and assembly and soldering techniques on strip board. Okay, we will look into another type of board which is available in the market that you can use for designing electrical and electronic circuit. So strip board is widely used type of electronic prototyping board characterized by 0.1 inch, 2.54 millimeter regular rectangular grid of holes with wide parallel strips of copper cladding running in one direction all the way across one side of the board. So basically this type of board you can use them for prototyping. Okay, for breadboard just now, that is for testing. Okay, prototyping ni adalah pre-construction lah. Okay, kita nak try buat dia punya soldering, nak measure all your components, lead tu cukup, kaki dia cukup panjang, how long of jumpers that you need, okay, how large of the area on your board that you'll be needing for designing later on. So you can use this. Okay, for this board, it is different in terms of the connectivity. Just now the connectivity of the breadboard is like this, but for strip board, they are parallel strip of copper. Means that connection dia akan dibuat secara parallel, running in one direction sahaja. Okay, means that kalau dia melintang, dia akan melintang. Kalau dia menegak, dia akan menegak sahaja. Okay, so di atas, ini bahagian bawah lah. Senang nak tengok bahagian bawah ni. So dia melintang macam tu je. Semua tu ada connection. Okay, ada continuity, connectivity. Okay, so what you have to do, you have to plan the component layout. Strip board used to make up permanent soldered circuit. So it is ideal for small circuits with 1 or 2 ICs, which is chips, the black IC tadi. But with the large number of holes, it is very easy to connect a component in the wrong place. Okay, so berhati-hatilah. Okay, it requires no special preparation other than cutting into size, because normally if you buy them, they comes in several sizes lah. So it might be that you are buying about this big of board, but you are using only quarter part of it, so you can cut them lah. It can be cut with the junior hacksaw or simply snap it along the lines of holes by putting on a bench or table and pushing hard. Okay, so you boleh potong lah. Ada cara dekat sini dia bagi tahu, guna hacksaw ataupun you nak guna bucu meja pun boleh. components are placed on the non-copper side, then the strip board is turned over to solder the component leads to the copper tracks. Okay, so kita letak bahagian yang tak ada copper, which is this side. Kita solder dia dekat belah bawah dia, which is this side here, ataupun this side lah. Okay, so this is the component example. This is the copper track belah bawah. So you solder them on this part. This is your strip board lah. Okay, this is your resistor, for example. So you have to turn them around for you to solder them. Okay, so the strip board layouts are shown from the component side, so the tracks are out of sight under the board. So layouts are normally shown with the tracks running horizontally across the diagram. Placing components on strip board requires care, of course. Kenapa? Sebab you have to turn them over. You place, dia takkan melekat macam breadboard. Breadboard, if you push the lid of your components, it will hold them there. So it will not move. But for strip board, nothing will hold your lead here. Okay, kaki-kaki ni tak akan dipegang oleh apa-apa. So dia senang bergerak lah. Alright. A large number of holes means it is very easy to make a mistakes. Okay, of course, if there are more holes, then it is much more easier for you to wrongly analyze later on lah. For most small circuits, the best method is to very carefully place the IC holders in the correct position and solder in place if you are using IC. So we have IC holder. The reason why we use the IC holder to make sure that it is not moving and to avoid overheat lah sebenarnya. Then position all the other components relative to the IC holder. So you letak dulu you punya IC holder, solder, and then build your circuit around that IC holder lah, dikelilingnya. So baru kita boleh plan our layout. Converting a circuit diagram to a strip board layout is not straightforward because the arrangement of component is quite different. Okay, of course. Daripada diagram, you want to convert into the strip board, it is not an easy task lah. Basically, you have to make sure that you follow the diagram to ensure the output is correct lah. Concentrate on the connections between components, not their position on the circuit diagram. Okay, this is normally happen for students lah. Okay, if you have a circuit like this, never design your circuit exactly as how they are placed here. Okay, you can place the components wherever you like. For example, R1 here. Let's say you want to place R2 this somewhere here or here or here, whatever you want. Okay, it is okay, no problem with that. Just make sure that they are connected lah. If they are not in the same connectivity, then use jumper. Okay, normally what happens, students, they obtain the circuit, dia akan design sebiji macam circuit ni. R1 dekat sini, R2 dekat bawah dia, betul-betul dia susun macam tu. If it is small circuit, then it is okay. If you have a large circuit with, for example, 30 or 40 components, then dia akan jadi susah lah. If you want to arrange exactly as how they are arranged in the schematic. Okay, so avoid. Jangan daripada schematic dia, daripada circuit diagram, convert betul-betul sebiji ke atas you punya board. It will be hard for you. Collect all parts to be used in the circuit to minimize the area used on the strip board. On the strip board, mount all components horizontally on the strip board to avoid damage or knock components. Okay, so we have two types of placement of components. We have vertical and horizontal. So dekat sini pun dia bagi tahu pakailah horizontally. Why? Because vertical is weaker. It is, you know, dia punya gravity from the strip board is lagi jauh, then dia lagi senang nak patah or everything lah. Lagi senang you nak tersenggol and everything. If it is horizontal, then it is neat. Okay, first one dia akan jadi neat, and then it is hard for you to accidentally move them lah. Okay. Alright. There are steps for you to design your, okay, for example, for this circuit lah. Alright. First, you download a stripboard planning sheet. Okay, easier planning. Use 0.1 inch grid paper mark to match the spacing of stripboard holes. Example of your graph paper. And try the stripboard planning sheet which can be downloaded and print out. Okay, you can find the stripboard planning sheet ni dekat online or Google. Orang ada share ramai. You just download them. And then working real size on the 0.1 inch grid makes it easy to follow the correct space for components but need to draw very neatly. Okay, so initially download the stripboard planning set. Okay, atau you boleh guna graph paper ataupun you can download them from Google. IC pins are numbered anti-clockwise around the IC starting near the notch or dot. Okay, the one that I've told you just now for ICs, which is this one. If the notch is on your left, it will start from here up until here. So it is anti-clockwise. Right? The diagram shows the numbering of pin 8 pin and 14 pin ICs, but the principle is the same for all sizes. Yes, depends on the number of pin. Ada yang 8 pin, ada yang 14, ada yang 32. Alright, but konsep dia sama. Letak notch kat belah kiri, then the bawah sekali belah kiri tu adalah first pin. Okay, here pin 1, pin 2, pin 3, pin 4. Yang ni for 14 pin sama juga, 1, 2, 3, 4, 5, 6, 7, and then dia pusing ke atas anti-clockwise untuk habiskan jumlah pin dia. Okay, so this is important. Component without suitable leads. Some components such as switches and variable resistors do not have suitable leads of their own, so it must be soldered using standard plastic coated wire, your jumper lah. For example ni push button ni. Okay, switches, push button switch ni lah. Okay, then dia tak ada kaki macam IC resistor, they don't have that. So you have to use your jumper to connect them to the board. Okay, so plan the component layout. Here you have 3 resistors, 1 IC, 1 LED and 1 capacitor. Okay, so place the IC holder, which is your IC punya connector lah, kaki dia, near the center of planning sheet with pin 1 at the top left as in the diagram. So pin 1 at the top left mana? Okay, so here. Okay, so this is the notch, this is your pin 1, pin 1, pin 2, pin 3, pin 4, pin 5, pin 6, 7 and 8. Okay. Mark breaks in each track under the IC holder with cross X. So the breaks prevent opposite pins of the IC being connected together. Okay, so here ada tanda pangkah X ni. You have to break them. Because why? Connection dia adalah from this point here vertically. Dia akan ada copper dia dekat bawah ni. So if you don't break this line here, means that pin 1 dengan pin 8 akan ada connection. So you break dekat sini, patahkan dia punya copper line tu, so the connection akan putus sampai dekat takat ni je. And then this point dia akan start sampai ke hujung. Means that dia tak ada connection between 1 and 8, 2 and 7, 3 and 6, 4 and 5, no connection. So you pecahkan dia lah, patahkan. Alright. Mark the upper supply tracks positive VS and 0 volt. Choose track which are 2 or 3 spaces above and below the IC holder. So that is for positive and 0 volt ni untuk your negative. Okay, so make sure cari lebih kurang 2 ke 3 line atas daripada IC, atas ataupun bawah pada IC, to give some spaces lah. Now add the wire link. Draw the blob, which is titik ni, at each end of the link. The link are vertical because the stripboard tracks make the horizontal connection. So like I told you just now, the connection of this the copper on this strip board is vertically connected. Okay, dia akan buat secara melintang. Alright, so use these dots to determine your connection lah. Alright. What is it? Draw all the direct link to the supply tracks plus V and 0 volt. Pin 1 connected to 0 volt and pin 8, 4 and 8 connected to VS. So kita tengok betul tak? 4 and 8 connected to VS. 1 is connected to 0. So which is this is 8. 1, 2, 3, 4, 5, 6, 7, 8. So 4 connected to VS. 8 is connected to VS. 1 is connected to 0. Okay, so just directly connect them. And then draw any links required between pins on the same side of the IC. So if there are any, nanti kita tengok links to pins on the other side of the ICs by connecting both of them to an unused track above or below the IC. The diagram shows pin 2 and 6 are linked this way. So kita tengok 2 and 6, they are connected together and then will be connected between R2 and C1. So pin 6 and pin 2. So how do we connect them? 1, 2, this is pin 2, which will be connected to this row, and it is connected to this line here, which is connected to pin 6. So pin 2 connected to pin 6. This is this is 2 going to this part here. This is 6. All right. Draw any links required between pins on the same side of the IC. So if you have the same side of the IC which are connected together, so you can connect them lah. For example, if you have pin 1 connected to pin 3, so just make the connection between them. Okay. So what's next? Okay, add components which will be mounted on the strip board such as resistor, capacitors or diodes. Make sure to allow for their size, which determines the minimum number of holes and sometimes the maximum as well. Label the components to avoid confusion. So this is important. Always label them. Connections which do not involve the ICs are made using an unused track. For example, R3 and LED are connected by an unused track above the IC. So kita tengok R3 and LED. R3 and LED is connected to pin 3 and then going to 0 volt. So example, resistor R3 and the LED are connected by an unused track above R3 and LED here. Okay, so R3 and LED, they are connected together. How? By this line on top of this IC, which is this blob until this blob. Sebab apa? Sebab this line horizontal dia ada connection. So you tak perlu pakai jumper lah. You don't have to use jumper. So this point here and this point here are connected together. Okay, and then the other pins of LED is connected together with this point, which is pin 1, where it will be connected to 0 volt. So kita tengok betul tak? So dia connectkan kepada pin 1, which is connected to 0 volt. So you obtain the pin 3 and pin 1 together. And then watch for alternative arrangements using the links already made. For example, the LED needs to connect to 0 volt. Okay, ni yang saya cakap tadi lah. You basically can, okay, from this point here, you can connect to this line of 0 volt, boleh. But we know that pin 1 is also connected to 0 volt. So you just can put them into alternative link. So linkkan dia, this block with this block, which is connected to 0 volt lah. The one that I've told you just now lah. Okay, so that is for alternative arrangement. R2 needs to connect from pin 7 to pin 6, and it could do this directly by mounting it vertically. So pin 7 and pin 6, betul tak? R2, which is connected to pin 7 and pin 6 and 2 just now. So you can do them vertically. So where is R2, which is this one? Okay, so it is connected to this blob, which is connected to to pin 6, and this line here, it will be connected to pin 7. So that's why you have to put them vertically. Alright. Add wires to components which will be off the strip board, such as switches. Macam ni tadilah. This part here. What is it? Okay, this part here. Kalau perlu, kita pakai jumper. This should normally be on the left and right of the edge of the board, starting by adding the battery clip or power supply leads to the positive and 0 volt tracks. Okay, so you can place them here, the positive red wire and the negative black wire. Masukkan kepada you punya supply. Check the plan very carefully by checking every connection shown on the picture diagram. A good way to do this is to work around the ICs pin by pin. Okay, that is the way. Okay, you check daripada IC, first pin is connected to where, second pin is connected to where, third pin is connected to which pins. So that is how you determine ada salah atau tak ada salah of your circuit lah. Okay, works around your IC. Look for ways to improve the plan. For example, it may be possible to eliminate an unused track by moving a supply track nearer to the IC, this part here. But make sure there is still sufficient space for the components. It may also be possible to move links and components closer to the IC horizontally to make the area of board required a little smaller. So depends on your design, how large, how small you want your design to be. Okay, so from this connection here, it should be the same with this layout of your circuit diagram. Okay, finally, check the plan again and make a neat copy fully labeled with all the component references or values. Work out the size of strip board required. Notice that an extra hole has been allowed on the left and right to avoid soldering at the end of track. Okay, so itu untuk kita punya holes, untuk kita lekatkan kepada kita punya box or whatever. Okay, so this is the final design of your circuit of this one just now. Okay, so if you look at it, it is using 8 tracks of strips multiplied with 20 holes. Okay, 1, 2, 3, 4, 5, 6, 7, 8. Horizontal, vertically 20 holes. So instead of they are too big, then it is become as compact as you can design lah. Alright. So what I want you to do for this session lah, for this class later on, malam ni. Okay, I want you to analyze this circuit with this circuit diagram. Make sure that they are connected accordingly. If there are none, if let's say you find any of this connection here is not correct according to the diagram, please tell me on the next class. Alright, so I want you to take your time, about 5 minutes, compare this strip board with your circuit diagram. Betul tak connection dia? Kalau tak betul, tell us, then we will discuss together. In case if you don't understand, yang ini connection dia, where does this connection goes? Kenapa dia tak ada jumper? Kenapa dia tak connect ke mana-mana? Then you tell me on next class. Kita akan discuss balik. Okay. Assemble on the strip board, resistor, inductor. Okay, normally we use 5 holes for half watt, for quarter watt 4 holes. Normally kita pakai 5 holes lah. IC 4 holes, capacitor 2. The reason why, because capacitor ni dia melonjong, okay, dia panjang. Transistor normally 3 lah, because we have 3 pins for transistor. Component lead bender. Okay, this is the thing that I want to tell you just now about bending the components lead. Okay, so you have the measurement here. If you have this bender, means that you have the measurement. Okay, 0.8 inch, 0.7, 0.75, 1 inch. Okay, it is up to you. So these are the what we call it, recommended lah. How do you bend your components? Okay, normally kita buat yang macam ni lah. Okay, yang horizontal ni tak payah pakai lah, unless kalau you betul-betul out of space, dah tak ada space sangat, baru boleh buat macam ni. If it is not, then use this model here. Okay, so bending technique, so make sure you are bending them around half inch from the body. Okay, ambil jarak sikit baru you bend. Don't bend them directly dekat body ni. Dekat body ni keluar, you terus bend ke bawah. No, dia akan senang patah. Okay, ini untuk professional lah. You nak save space, instead of 5 holes, you pakai 3 holes only. Tapi banyak kerja lah, you nak kena bengkok-bengkokkan and everything. Okay. Soldering technique, kita akan refer to soldering techniques in chapter 5 later on, how to solder these things. Ni ya. All these silver dots. Okay. Alright, macam ni lah. Macam ni kira cantik lah for our level. Even my level pun, kalau saya dapat buat macam ni pun, saya dah happy. Sangat cantik, halus. Okay. Tapi kalau sekarang, if you ask me to do pun, saya tak akan dapat macam ni balik lah. Saya akan dapat besar-besar macam budak sejuk. So, it takes time for you to master the soldering techniques lah, because you need practice to make sure that it is perfect lah, perfect size, no crossover, tak terconnected dengan line lain and everything. Okay, so we will go into the chapter 5 on this soldering technique later lah. Kita baru dekat chapter 4. Okay, so that's it from today. For today, I think that is the topics that I want to discuss with you. To complete chapter 2 on our circuit construction, measuring technique and electronic laboratory equipment, as well as for chapter 3, which is the electronic circuit development by using strip board lah. Okay. Okay, do you guys have any question?
No, sir.
Okay lah, buat masa sekarang it looks okay lah, because everything is theory. I will upload later on. I will share the link of my lecture just now through your VLE for your reference lah, for your later reference lah. But for today, I want you to try to analyze the thing that I told you just now lah. The one that have been designed on the strip board with the initial circuit diagram. Saya nak you try compare dia punya connection, analyze, cuba determine ada tak salah buat connection, or if there are any connections which you don't understand, you couldn't find the connection, we will discuss on next class. Okay, you tengok ada mana-mana you tak faham, you beritahu sir, yang ni saya tak faham, daripada from this pin to this pin there are no connection, macam mana dia connected. So kita akan bincang balik. Boleh tak?
Boleh, sir.
Yeah. Okay, last round, any question?
No, sir.
Okay, if there are none, then I'll take the attendance from this lah, from the download attendance list ni yang ada pada Teams ni. Okay, so I will end our class here. InsyaAllah, I'll see you. When is it? Tomorrow, isn't it? When is our next class? If I'm not mistaken, it is tomorrow. It's tomorrow.
Khamis, sir. Khamis.
Khamis eh? Khamis pukul 12 eh?
Kami ke 12.
Sir.
Pukul 12. Okay.
Yes, sir.
So nanti itulah, analyze dulu circuit yang saya cakap tadi, and then we will discuss on Thursday before we continue our lecture. Alright? Okay guys, I'll end the class here. I'll see you on Thursday insyaAllah. Assalamualaikum and good afternoon.
Thank you, sir.
Waalaikumsalam, sir. Thank you.
Thank you, sir.
Thank you, sir.
Okay. Apa ni Mami? Mami? Mami hantar apa ni? Oh. Sekejap lagi.
Siapkan yang online ni. Ini sudah ya.